Hi friends, welcome back to Geology Guide channel. Today in this video, we are going to see about an introduction to origin of Earth. Those who are newly watching our channel, do subscribe for more videos. Theories. So before going into the topic, let's see what are the theories were first proposed by different scientists about the origin of the Earth. So theories may be two types, either evolutionary theories or catastrophic theories. Evolutionary theories are nothing but, according to them, planets are formed as the evolution of the Sun. Example, Nebular Hypothesis. For catastrophic theories, it states that planets are formed by an accident or catastrophe. So it means that any planet is formed suddenly by an unexpected accident. So this may be due to close approach or collision of two stars. But since stars are so far from each other, the possibility of sudden accident is rare. So example of these catastrophic theories are Planetesimal and Gaseous Tidal hypothesis. So coming to Nebular Hypothesis. What is hypothesis? So a hypothesis and a theory is different from each other. So a hypothesis is nothing but a theory which is not scientifically proven. It is said to be hypothesis. Whereas a theory is said to be, it is scientifically or either experimentally it is proved. So Nebular Hypothesis, it was first proposed by German philosopher Kant in 1755. Later in 1796, the French mathematician named Laplace also advanced this hypothesis. So what this theory says, according to this theory, the Sun and the planets have formed from a disc-shaped rotating nebula. So what is nebula? A nebula is a vast cloud of hot gas. So gas to planets, how gas is converted into planets, it is about Nebular Hypothesis. Initially, there was a large, hot, gaseous nebula rotated about its own axis. Later, the gaseous materials lost their energy due to radiation and it gradually cooled. On cooling, the nebula gas contracted inwards and its speed of rotation increased to conserve angular momentum. The centrifugal force in the equatorial zone increased and the nebula in the equatorial zone bulges out. The whole process continues till centrifugal force become greater than the gravitational force. As a result, gaseous rings separated into many. Such separated rings consolidated into planets at final stages. Those are called as planetoids. So planetoids are breaking up of one ring into many fragments. Then after the fragmentation, the central mass remains unchanged but continues to shrink. Then finally it becomes Sun. However, this Nebular Hypothesis has some disadvantages, such as they do not explain the energy distribution within solar system. According to this hypothesis, if the mass is high, there should be a high angular momentum, but 98% of angular momentum is associated with planets, whereas only 2% is associated with Sun. So this hypothesis fails here. And also, there is no enough mass in the rings to provide gravitational attraction for condensation of gas into individual planet. So based on these factors, the Nebular Hypothesis failed. Planetesimal Hypothesis. This hypothesis is also called as dynamic encounter theory. In 1904, American scientists Chamberlain and Moulton proposed this hypothesis. According to this hypothesis, the Sun existed before the formation of planets. In that situation, when another star approached the Sun, gravitational force pulled out the materials from the Sun. During such pulling action, large quantity of gases broke into space. The ejected gas on cooling became solid fragments. They are called as planetesimals. So such broken gaseous particles revolve around the Sun in different orbits and they collide with each other and aggregated into individual planets. This theory also have both merits and demerits. So the merits include occurrence and occasional fall of meteorites. So this is the best example of planetesimal theory. Also this hypothesis explains presence of highly elliptical orbits with smaller planetary bodies and circular orbits of larger ones. So coming to demerits, it fails to indicate that gases would disperse in the space rather than condense into planets. Also, the probability of close approach of any two stars is extremely rare. So coming to third hypothesis, Gaseous Tidal hypothesis. It was proposed by Jeans and Jeffries in 1925. This theory is the modified theory of biparental origin of solar system. This theory says that the planets were formed from the gaseous tide when the Sun is approached by a very large star. So when a large star is approaching the Sun, a gaseous filament was ejected into the space by the Sun and split up into number of fragments. This was similar to planetesimal hypothesis. Then the split up gaseous molecules on cooling became planets and the remaining broke into small pieces to form a group of planetoids. As seen earlier, this hypothesis have also both the merits and demerits. So what are the merits? The merits include the rotation of the gaseous filaments account for the concentration of angular momentum in the planets. So it is very simple hypothesis explaining the formation of Earth. So coming to demerits, it doesn't explain the process of formation of planets because it seems mysterious. So encountering of Sun by another Sun is rare. Also, the ejected gases would have dispersed into the space rather than becoming an individual planet. Binary star hypothesis. This theory was put forward by Littleton in 1938. Before the formation of the planets, the Sun had a companion star. So in such case, when a companion star is approached by some other star, the companion star recedes away from the Sun. So when receding away, a gaseous filament was torn from it and remained with the star, which in turn becomes planet. This hypothesis is similar to Gaseous Tidal hypothesis, which was proposed by Jeans and Jeffries. So with this, I would like to conclude our video. So today we have seen about Nebular Hypothesis, Planetesimal Hypothesis, Gaseous Tidal Hypothesis, Binary Star Hypothesis. For more videos, subscribe our Geology Guide channel and stay tuned. Thank you for watching.